Hello and welcome to another video by Training Made Clear. Today we'll be doing lesson number 5 on pressure. This is part of the Imperial and the Metric System series, and today under pressure we'll be doing part number 2. This is to help you understand pressure more clearly. If you look at these two pictures, you will see on the left there's a long pencil with a sharp point, and on the right there's a shorter looking pencil with a blunt point. Why do the two sides feel different? Is the force the same on the two ends? The answer is yes, it is. Why does the tip push further into the skin than the blunt one? The reason is because the force acts on a smaller area, thus increasing the pressure. As we look at the next slide where we will discuss the formula, this picture will make some sense. So what is pressure? Pressure is the physical force exerted on an object. Pressure is the force applied perpendicular to the surface of an object per unit area. The formula pressure is equal to force divided by area. If you look at this, the pencils, you can see the sharp pencil, the area is smaller. That's why the force seems greater. Because looking at the formula, the more we make the area smaller, the greater the force becomes. So if you can't remember this formula, maybe a good way is to try and remember this triangle where you have F at the top and P times A at the bottom. So if you are looking for the force, then it will be the 2 at the bottom, P times A. So force is equal to P times A. But if you're looking for pressure, then it is F divided by A. And if you're looking for A, then it is F divided by P. Here we have a block 6 inches long and 4 inches wide, cut up into 1-inch squares. So in total we have 24 of these blocks. So we have 6 inches times 4 inches, which equals 24 square inches. If each block is 1 pound, then the total weight of the block, the total block, is 24 pounds. Force divided by area is the pressure. That will mean that we take 24 pounds divided by 24 inches, and that will give us 1 pound per square inch. This is a very important diagram to try and remember and keep in your head. So if you look at this, we're looking at a couple of different kinds of pressures. This point here is called absolute zero. Absolute zero is like standing at sea level, and all this air that is above you right up to the end of the atmosphere, the weight of that air is called the atmospheric pressure, which is roughly about 1 bar or 14.7 psi. Now, if you could suck all that air out of there as you go down, all this area that you're going down is called the vacuum area, vacuum pressure. So the more I can suck out, the better my vacuum. If I could suck all the air out, I would have a perfect vacuum, and that would be a negative 1 bar, which is the same as negative 14.7 psi. And we normally measure vacuum in inches of mercury, and this would be equal to 30 inches of mercury. Now, any pressure from here all the way past atmospheric pressure and above is called absolute pressure. So absolute pressure is the pressure above absolute zero. Vacuum is all the pressure below atmosphere. Gauge pressure is the pressure above atmosphere. And differential pressure is the difference between two pressures. We will look at this in another diagram at a later stage. The fundamental pressure types. Absolute pressure. The definition, pressure measured relative to a vacuum, a perfect vacuum, zero pressure. The key point, it is the true physical pressure. Absolute zero pressure. The definition is the theoretical pressure of a perfect vacuum, meaning a space with absolutely no matter or particles, resulting in zero kinetic energy and no molecular motion, serving as the baseline zero for absolute pressure scales like PSI, pounds per square inch, absolute. Atmospheric pressure. The definition is pressure exerted by the weight of the Earth's atmosphere. The standard value is 101,325 pascals, which is 1 atmosphere, or the same as 1,013 bar, or 14.7 psi. And this one we will visit as well when we talk about that one diagram that will be coming up later. Gauge pressure. The definition is the pressure measured relative to atmospheric pressure. The key point, zero gauge pressure is equal to atmospheric pressure. Vacuum pressure is negative gauge pressure. The definition, pressure below atmospheric pressure measured relative to atmosphere. Now, we're going to look at a lot of different types of pressures now, and I'm not going to read through each one's definition. So take a snapshot of these slides as you see them, and hopefully you will be able to remember them all. So we have gas pressure, we have liquid, hydrostatic head pressure, we have vapor pressure. In flow and motion related pressures, we have static pressure, dynamic pressure, total stagnation pressure. In directional and surface pressure types, we have normal pressure, lateral pressure, and contact pressure. All these bullets that I've put on here is probably some pressures which you may not have actually heard of before. Material and structural pressure types. We have stress, mechanical pressure in solids, bearing pressure. Measurement and instrument-based pressure types. You must have heard of differential pressure or manometric pressure. And special environmental pressure types. Partial pressure, osmotic pressure, capillary pressure. Maybe you've heard of that before. It's like a medical term, I would imagine, and radiation pressure. Industrial and applied pressure types, operating pressure, design pressure, burst pressure. Burst pressure is like a vessel that's been fitted with what we call a bursting disc. Bursting disc is designed to rupture at a certain pressure. So if your bursting disc is set to rupture at 1000 psi, then when your vessel gets to 1000 psi, that bursting disc will blow up, it will burst, and all the pressure that's inside the vessel will be released. The relief set pressure, that's different. It's kind of like a burst pressure, except this is with a safety valve. And it's the pressure at which the safety valve will open. And once you reach that pressure, the safety valve will blow off whatever pressure is there. And as soon as the pressure comes below, let's say it was 1000 psi, it comes below this, the safety relief valve will reset and close. And then the pressure will build up again and will blow off again. And it will keep doing it. It's different to the burst pressure. The burst pressure, once it blows off, you can't pressurize the vessel anymore because there's like a big hole in it. You can say the pipe is open. Biological and medical pressure types. Blood pressure. Sure, you've heard of blood pressure. Intracranial pressure and intraocular pressure. Then you also have environmental and altitude pressure types. Barometric pressure. Sure, you've heard of that, a barometer. This is what we use to measure the weather. Altitude pressure. Common units of pressure measurement. Pounds per square inch is one. Inches water gauge is another one. Bar, millimeters of mercury, millimeters of water. Those are the most common ones that we use. Unit multiples. 1 million equals mega, and the symbol is M. 1,000 is equal to kilo, and the symbol is K. 1,000th is milli, and the symbol is M. And 1 millionth is a micro, and the symbol is the U with a tail on it. If you look at the different scales here, we've got pascals, bar, millibar, psi, inches water. So 100,000 pascals is the same as 1 bar, which is the same as 1,000 millibar, which is the same as 14.5 psi, which is the same as 402.156 inches water. Pressure units that we normally talk about is Pascal, which is a SI unit, bar, which is also a SI unit, and PSI, which is an imperial unit. Now, here is the atmospheric pressure, also called barometric pressure. It's defined as the force per unit area exerted against the surface by the weight of the air above that surface. The pressure at sea level is approximately 1 atmosphere. So this is basically like when you're standing at absolute zero, and this is the air above you. This is the value in pressure of that air. That could be equal to 760 millimeters of mercury, or 14.7 psi, or 101 kPa, or 1,013 bar. Pressure measurement and pressure relationship. Gauge pressure is called PSIG. Absolute pressure is called PSIA. Vacuum pressure is PSIV, or inches mercury. Atmospheric pressure is 14.7 psi. Atmospheric pressure, also known as barometric pressure, is the pressure within the Earth's atmosphere. The standard atmosphere is a unit of pressure defined as 101.325 Pascal, which is equivalent to 760 millimeters mercury, or 29,9212 inches mercury, or 14.696 psi. Now, if you round some of those off, the 29,9, we talk about that basically rounded off to 30 inches of mercury is a perfect vacuum. 14.7 psi is the atmosphere. Now, as I said, we will come back to those other diagrams that we looked at before. If you stand in here at sea level, here's the sea, and here's the earth going out up into a mountain. If you can see how tightly packed the air molecules are here, and they become much looser as you go higher. This is because the air is being compressed. The higher you go, the less compressed it is. And that is also why mountain climbers, when they go much higher, like Mount Everest, they only get 1/4 of the amount of air that is down below here at sea level. And that's why they struggle to breathe, because there's less air up there. So if you could count up all of this air and weigh it, it would come to those figures that we had over there. That would be the equivalent weight of that. Now remember, in the part 1 series, we spoke about header pressures, and we said that 10 meters of water is the same as 14.5 or 14.7 psi, which is very close to this figure here. So you can almost say that when you are standing here at sea level, it is like having 10 meters of water above your head. That's the weight of this air, that's what's on you. So if you went into a swimming pool to the deep end and your head was 10 meters underwater, that pressure of water that is on top of you is what you would feel if you were standing by sea level and feeling that air resting on your body. We actually don't feel it, but that is the reality of the weight of the air. So basically what we're saying in this whole scenario here is that higher pressure is at sea level because of the air particles that are more tightly packed. It weighs more. The higher you go, the less it will weigh. And that's why mountain climbers basically struggle to breathe, because they have round about a fourth, and here it says here, they have about 1/4 of the pressure at sea level. So they have much less air up there. So atmospheric pressure at sea level is 1 bar or 760 millimeters mercury, which is 30 inches mercury. Pressure unit conversions, useful units and conversions. The following conversion factors should help in dealing with various units. If you can remember 1 psi equals 51,714 millimeters mercury, great. I would not remember that easily. I might remember it's 2 inches mercury, roughly 2, because if you round that off, so that might be an easier figure to remember. 1 psi is 2 inches of mercury. I used to remember this one, and I used to remember it as 27,7 inches of water. So 1 psi is 27.7 inches of water. And if you can remember, this one is 6,89 kPa. Then these figures that I've done in dark are the ones that you probably will be able to remember the most. 1 atmosphere, which is like 1 bar, is almost the same figure as that one. Common units of pressure measurement: inches water gauge, or inches of mercury; bar, millimeters of mercury; millimeters of water; and pascals. Now, in this, I'm basically saying, yeah, if you can remember, a few years ago, we used to calibrate instruments for 3 to 15 psi for a 0 to 100 output indication. Those values were imperial values. Nowadays, we calibrate things for the metric values. So the 3 to 15 changed to 20 to 100 kPa values. So that would mean that 3 psi is the same as 20, or roughly the same as 20 kPa, and 15 psi is roughly the same as 100 kPa. So if you read what I've written here, so a rough conversion, if you had to divide 20 by 3, you would get close to 7. It actually works out to 6,66 kPa. If you do the same with the 15 psi and the 100 kPa, divide 100 by 15, again you will get 6,66. This 6,66 is very close to this value that you see over here. So if you can't remember this value, and you can work it out from this, because you may have dealt with those values before and the new values that are being dealt with here. So that might help you to get a very close figure on that figure there. Okay, useful units and conversions. Pressure is defined as force per unit area. The units of measurement are psi, pounds per square inch; millimeters Hg, it's mmHg is millimeters of mercury; INHG is equal to inches of mercury. INH2O is inches of water. kPa is kilopascal, and atm is atmospheres. Now, this is a nice conversion chart which can help you to solve some conversions just by reading them off the chart. So if you want to know what 1 atmosphere is equal to, it would be the same as 14.696 inches pounds per square inch, or the same as 1,0332 kilograms per square centimeter, and so on. So 1 atmosphere is equal to these values that you have here, whatever you want. So if you want inches of water, you go 1 atmosphere is the same as 407.14 inches of water. This is a better one because it has a lot more in it, but it works the same as the previous chart. So basically, if you look here, we would say 1 bar is 100 kPa. 1 bar is also the same as 14.5 psi. It's the same as 1.02 kilograms per centimeter squared. And 1 atmosphere is 101.325 Pascal. Now, the following that we're going to be dealing with here is just to help you understand interface level a little bit better. I'm going to be showing you some diagrams just now where you will see how you calculate the interface level, because as you look at the drawings, you will see what happens with a vessel. So there are 2 solutions. The solution number 1, method 1, and solution method number 2. These are 2 different ways that you can actually calculate this, and you can choose which one your head wraps around easier on. So take a snapshot of this slide, and then when we come to the drawings, you can decide which one of these 2 ways of calculating seems better for you. All right, this is the vessel. Yeah, you can see the vessel, and this is the area which will be filling up with either water or oil or both. So if you look, water is blue, so that's our water level. Oil is the brown one, which is this one here. And this one over here, we've made it a greenish color, which is the glycerine. Okay, so this is our wet leg, which doesn't change. It's always filled with a constant solution, and that we have to take into consideration. So the leg that will be changing will be this one, and we will be looking at this differential pressure that is formed here. So what will the pressure be on this level transmitter when the water level is at 0, but your oil is full? So it's full of oil, but we've got 0 level for water. So the formula is that the pressure is equal to the height of the water times the SG of the water, plus the height of the oil times the SG of the oil, minus the wet leg, which is the height of the wet leg times the SG of the glycerine. And if you look at these values that are put in here, these are the values that you would have for 0% water at that point there. Your water level is 0. So water, the height is 0. 0 times whatever the SG is, that was 0.944. So 0 times 944, that'll give you still 0, plus the 630, which is this distance, which is now oil. The oil is full, times that SG. Okay, so times the water, and sorry, as the oil, so the oil SG and the oil height, you multiply those 2. You do the same with the glycerine, it will be 630, and you can see basically in the formula there. That's the 630 for the glycerine. This is the 630 for the oil. And this is the 0 for the water. These are the SG values that we multiplied with. And at 0% water, the differential pressure that we have here, or the pressure that you will supply here, will be minus 320 millimeters of water. Okay, that's for the 0 level. When your level comes up to 25%, now you're at 25%. You're on this line over here. This is the calculation that we had in the previous one year, which was written below. As you see, I've only done for the 0 level and for the 100% level, just so that I can make it nice and big for you there so that you can see, because you might not be able to read these figures very carefully. But once again, yeah, we have the 157, which is that, the water level, multiplied by the water SG, plus whatever's the left of that, which would be 630 minus that one, which will give us this value here, 472, times the SG of the oil, which is 0.754, which is that SG there. And then we do again the glycerine side, which will be this, and you would land up with the value of minus 290.745 millimeters of water. And at that spot, we would be 25% level, and our output should be 8 milliamps from our transmitter. Now, if you do the same for the next slide, which will be 50% level, we'll have 315 here and 315 there. This SG, that SG, and we'll have 630 for that SG. So if you see that formula there, you'll see all the values are in there at the bottom. Same will happen for the 75% level. We'll have this value, that minus that will give us that value, and our SG for our glycerine will stay the same. So the value for the level pressure there will be minus 231 millimeters of water. And our level will be 472 millimeters, and the output will be 16 milliamps. And the final one is when your water is full and your oil, there's no oil. The oil is now on top, so we're not measuring any more oil now, we're just measuring water. This is the interface. There'll be times when you'll be measuring either only oil or either only water, or water and oil at different measurements. And these are the values that you would punch into your transmitter to set your 0, your 50%, and your 100%, and those are the outputs that you will read. So that's the way that you can do interface. And I hope this clears up a lot of things for you, because a lot of people struggle with this and they face it often in a day. I hope this video was of value to you, and I hope that if you did like it, that you'd show you like it, subscribe to it, share it with others, comment on it if you wish, and follow. And thank you for watching.